Okay, so in this video, you will learn about sensitivity analysis. Okay, there are three types. The first one is when the coefficient of the objective function, what happened to the optimal solution? Okay, so usually the coefficient is the unit profit or the unit cost. So in this example, the red dot here is the optimal solution. Okay, so we want to find the effect of changes in the objective function coefficient on the optimal solution. Okay, so this is the original objective function. Okay, so the coefficient of x1 is 8 and coefficient of x2 is 5. So when we reduce the coefficient of the x1, okay, from 8 to 4, okay, see what happened. Okay, when it changed to 4, the optimal solution is still not changed. Okay, when it becomes 3.75, okay, when it becomes 3.75, the solution is along this line. Okay, the solution is along this line. If we decrease the coefficient, okay, for example, if we take 2, the coefficient of x1 is equals to 2, then the solution change. Okay, the optimal solution change. It's no longer the original one, but it becomes this new one. Okay, now, okay, just now we found out that the lowest the coefficient can go is 3.75. After that, if we decrease it more, the solution will change. Now, what happened when we increase it? Okay, from 8 to 10. If we increase it to 10, the solution is still here and the solution is also along this line. But when we increase it again, okay, increase it to 11, the solution is no longer the original one, but it changed to another point. Okay, so the range is between the range of the coefficient of x1 is between 3.75 and 10. Okay, this is what we call range of optimality. Okay, characteristics of objective function coefficient changes. So when we change the objective function coefficient, there is no effect on the feasible region. The slope of the level profit line changes. Okay, profit line here is the objective function. Okay, the slope is kecerunan. The slope changes. The slope of the objective function changes. Okay, if the slope changes enough, a different corner point will become optimal. Okay, if the slope change out of the optimality range, then a different corner point will become optimal. Okay, this is another example. Okay, this is the original optimal. Okay, when you change it out of the optimal range, another corner point will become the optimal solution. Okay, now how do we calculate the optimality range? Okay, I'm using example 3.62. You can find it in the textbook. So in this example, this is the objective. Okay, in this example, this is the objective function. Okay, this is constraint and this is another constraint. Okay, this is the optimal solution. Okay, first, find the slope for the constraints. Okay, for the constraints. Okay, find the slope for the constraints. Okay, for this constraint, we have 2x1 plus x2 equals to 8. Okay, since it is line, so we write it equals because it is a line. Okay, and then we have so the slope here is minus 2. Okay, the slope here minus 2. Okay, this is okay, you still remember, right? This one, what do you call it? Mx plus c. Okay, so this is the slope. Okay, so this is the slope. Okay, minus 2. And for this constraint, we have x1 plus 3, x2 equals to 8. And so the slope is minus 1 over 3, or you can write it minus 0.333. Okay, and then for the objective function. For the objective function, the general form is c1 x1 plus c2 x2. Yes, since this is x2, so we write x2 here. Okay. Okay, minus c1 over c2 x1 plus z. So the slope here is minus c1 over c2. Okay, in this case, we have, in this problem, we have 3x1 plus 2x2. So the slope here is minus 3 over 2 x1 plus z. Okay, z is a constant. In this case, we don't know the value of z, and we only want to find the slope, so you can just write it as z. Okay, so the slope here is minus 3 over 2, or minus 1 over 5. Okay, look at the graph. The slope is between machine 1 and machine 2. Okay, the constraint 1 and constraint 2. So you can write the slope for the slope for the objective function, okay, minus c1 and c2, and it's between these two, okay, between these two lines. So the range, the slope is also between these two number. So between minus 0.333 and minus 2. Okay, we want to we don't want to write it in minus here, so we multiply it by -1. So we have 0.333 C1 over C2. Okay, so this is the optimality range. Sorry, this is not the optimality range, but this is the ratio that C1 over C2 can vary. Okay, so C1, the ratio C1 over C2 can vary between 0.333 and 2. Never mind, we can still call it optimality range. Okay, now suppose that the Z is changed to Z is changed to this is the new Z. Okay, the coefficients are changed. So okay, x2 here. Okay, so the slope is minus 1.4. Okay, the original slope is, okay, the original one is C1, C2 minus 0.333. Okay, so this slope is still between, okay, 0.14 is still between this range. So the optimal is not changed. Okay, now suppose that one coefficient of the objective function is fixed and we want to find it the range for the other coefficient. Okay, for example, we fix the value C2 at 20 and we want to find the optimality range for C1. Okay, optimality range for C1. Okay, so we have this optimality range. Okay, just substitute C2 as 20. So we have so this is the optimality range for C1. Okay, same thing with optimality range of optimality range for C2. Okay, so we fix C1. Okay, fix C1 at 30. So we can get C1 over C2. Okay, C1 we fix it at 30. Sorry. Betul dah ni. So C2 and another one. Larger than or equals to 15. so you can write C2 larger than 15, less than 90. Okay, so this is the optimality range for C2.